New materials technology will enable the creation of more sustainable and environmentally friendly aircraft and spacecraft, reducing the impact of aviation and space travel on the environment. Conclusion. The development of new materials technology has been a key driver of innovation in the aviation and space industry, enabling the creation of lighter, stronger, and more efficient aircraft and spacecraft. New materials technology has also improved the safety and reliability of aircraft and spacecraft components, reducing the risk of accidents and failures. The future of materials technology in the aviation and space industry is promising, with continued advancements in composite materials, high-temperature materials, smart materials, and nanomaterials. These new materials will enable the creation of even more advanced and sustainable aircraft and spacecraft, with reduced fuel consumption and emissions. As the aviation and space industry continues to grow and evolve, the development of new materials technology will remain a critical area of focus, driving innovation and progress in the industry. In conclusion, the development of new materials technology has played a crucial role in the advancement of the aviation and space industry. From composite materials to smart materials and nanomaterials, these advancements have enabled the creation of lighter, stronger, and more sustainable aircraft and spacecraft. As the industry continues to grow and evolve, the development of new materials technology will remain a critical area of focus, driving innovation and progress in the industry. The future of the aviation and space industry is exciting, and new materials technology will undoubtedly play a key role in shaping its continued growth and success. Applications of new materials technology in aviation and space industry. The applications of new materials technology in the aviation and space industry are vast and varied, enabling the creation of more advanced and efficient aircraft and spacecraft components. Some of the key applications of new materials technology include lightweight and strong aircraft and spacecraft components, composite materials, such as carbon fiber and fiberglass, are lightweight and strong, enabling the creation of lighter and more efficient aircraft and spacecraft components such as wings, fuselages, and rocket fairings. High-performance jet engines and rocket engines, high-temperature materials, such as titanium and nickel alloys, are used in the construction of high-performance jet engines and rocket engines, enabling higher thrust and greater efficiency. Adaptive and responsive aircraft components, smart materials, such as shape memory alloys and piezoelectric materials, can change their properties in response to external stimuli, enabling the creation of more adaptive and responsive aircraft components such as wing flaps that change shape in response to airflow. Advanced sensors and electronics, nanomaterials, such as graphene and carbon nanotubes, are used in the construction of advanced sensors and electronics, enabling more precise and accurate measurement and control of aircraft and spacecraft systems. Challenges of new materials technology in aviation and space industry. Despite the many benefits of new materials technology in the aviation and space industry, there are also several challenges that must be addressed. Some of the key challenges include cost. New materials technology can be expensive to develop and manufacture, which can make it difficult for smaller companies and organizations to adopt. Certification. New materials technology must be certified by regulatory agencies such as the Federal Aviation Administration, FAA, and the European Aviation Safety Agency, EASA, which can be a lengthy and complex process. Safety. New materials technology must be thoroughly tested and evaluated for safety, as failure of aircraft and spacecraft components can have catastrophic consequences. Sustainability. While new materials technology can enable the creation of more sustainable aircraft and spacecraft, the production and disposal of these materials can still have an environmental impact, which must be carefully managed.